Uma, you can start, ma.
Okay, ma'am. Hello, everyone. I'm Uma from Creactive team. Creactive is a platform of like-minded individuals committed to learning beyond textbooks. Through our weekend talk series, we bring together experts from diverse fields to share their knowledge, experiences, and innovations, helping us to understand the world from different perspectives. Today is our 212th talk. On behalf of National Science Day, we conducted competition for students. So today we are announcing their results too. We are having two sessions today. After session, we'll have questions for audience regarding session. And the winners have the exciting prize. So please pay your attention. You need to submit your answer to the number on the screen. Ma'am,
Yeah, go ahead.
ma'am,
On the
can you put number
yeah,
on the screen?
yeah. 1 minute. Are you able to see?
Yes, ma'am.
Yeah.
Please everyone note it down. Yeah, now we move to our first session. So today's first session is interplanetary mission of ISRO by our resource person Sri Amitabh sir from ISRO Ahmedabad. Before we start, a few quick notes. This session is being recorded. Please keep your microphones muted. Drop your questions into the chat box anytime and we will answer them at the end. Now, I would like to invite Sanvi from Creactive to introduce our speaker, Sri Amitabh sir. Sanvi, over to you.
I think she not joined. Maybe some issues in joining. Sanvi, are you there? Okay. Sir, you start the session. At the end, we can give introduction about you, sir. I think some network issue over there.
Okay, no problem. We can go ahead.
Okay, okay.
Let's start. Thank you. Just I am sharing my screen.
Yes, sir.
Is my screen visible?
Sir.
Okay.
Yes, sir.
Namaskar. Good afternoon. Greetings to all of you on the occasion of National Space Day. This is the third National Space Day. That is the historic day. 3 years ago, we have landed on the moon at the nearly same time. Nearly currently it is 5:10. So nearly this time period, we were having a very hectic and tense moment at the Mission Control Center at ISTRAC, Bangalore. So I remember just those days when that time the transmission was just started at nearly 5 p.m. to the public for seeing wherever our lander is going. Those images was coming from the lander imager. So thank you to the organizers today to give me opportunity to just give a glimpses of the planetary missions or interplanetary missions of India to you. So the first question arises that what are the different objectives for which we are going for any planet or moon or Mars or any celestial body. So first thing is to know about the formation, its age, and how it has evolved till today. So that is very important because if you take the case of moon and earth form nearly same time. with the same object. So why moon is not having the air, not having the atmosphere? It is a airless body. Why moon is having so many depressions called craters and boulders, that is stones and other things, and there is no life on the moon. So why it has happened so? How it has got form moon like this? And so knowing about that, similarly for Mars, why we have there the impressions of lakes or ponds or somewhat rivers. So why these type of impressions are there, but still life seems to be not exist on the Mars surface also. So is there any possibility in near future that Earth may encounter those type of problems what Mars has encountered or Moon has encountered? So know about how it has formed, what are the different activity has happened so that it has reached to the current state. Then know about its surface. How will we know about its surface? What is inside beneath the surface? So those interior properties we want to know. And we also want to know that if the surface properties contains some water or water ice somewhere, then probably life exists there, or probability of life to be created in near future. So that type of activity to find out the different type of metals or chemical or mineralogical composition there, so, and some ice formation is there, or some water hydroxyl molecules are there. So those things, if it is there, then we can certainly one day we can go there, and then we can put some human settlement, some bases on the moon. Currently, in case of moon, why I am talking more about moon, because moon is the nearest celestial body, which is very near to Earth, and moon is the only celestial body where human beings have landed. Crew missions has happened, and human up to now 12 persons have landed on the moon in different 6 missions of the Apollo. So we have the exact rocks, other things coming from the moon. Human has gone there and felt there the harsh atmosphere and other things. So we have experienced. That's why most and no other planet till date human being have landed. So now whenever we talk, we first go the nearest celestial body, and that is the moon. So in future, suppose now technology are changing day-to-day basis, and that is not far that when we have moon base somewhat in the lunar south polar area. Moon south or moon is also called lunar. It is a word normally used for the Earth moon is called the lunar. So lunar is having in few years, you will see there will be the human base, as well as chances once base will be created, then a space to reach. Then mining is also, why mining is required, because we are finding from the remote sensing data, whatever till now we have sent, I will show in the next slides, that different type of minerals, other things are available on the moon surface. So particularly the rare earth metal, which is having very significant these days in case of the semiconductor and other strategic things if we want to make. So mining is possible there, and then from there we can transport it back to Earth for getting the energy requirement, to fulfill the energy requirement of Earth. Then it may be the platform to go to any other planet, because you know moon's gravity is 1/6 of the Earth's gravity. So sending something from there is quite easier. It requires less propellant to send, less energy to send from there to the other planets like Mars or Jupiter or any other planet. Another thing we can also thought of, that if it is a planet, then from Earth to Jupiter, suppose we are going, we can stay at the moon and then again fill the propellant and go ahead with that. So that may be the platform for other planets. So if we take the types of missions for the planetary exploration, people consider normally 6 types of missions are there. One is called flyby. Flyby means if we just launch a satellite from Earth's surface, a spacecraft from Earth's surface, is go to the moon, not take full round in the orbit, just take one round, or in the way it takes photographs from or some information about the moon, collect, and then come back to the Earth. So that is the flyby mission. Suppose we are going to Mars or Jupiter, in the way moon is coming, then we take the photographs or some of the spectral signature we take, and from there we derive some informations about the moon. So that is the flyby missions. Then coming to orbiter. Orbiter is nothing but like Earth, we are having several artificial satellites for Earth observation or communication or navigation. Similarly for the moon, if we send some spacecraft that takes orbit around the moon in a particular defined circular or equatorial orbit path, then it is called the orbiter. So orbiter, most of the data currently got collected through the orbiter. Then lander and rover. Lander and rover, lander is the spacecraft which go there and land, and then rover comes out of the lander, or lander may itself become the rover, and then walk on the moon surface to collect the payload data for different science perspectives. Then coming to impactor. So impactor is the when we have started this, I will come in the next slide, that how the people have gone moon. First they tried to just impact to the moon itself. So go and impact there. Or suppose some orbiter is working there and it has fulfilled its mission. It has all the objectives has been completed. Then people at the last of the mission, they go and just impact on the moon surface, so that whatever the ejecta coming out of that, we can find out the nature of the soil there, nature of the elements present in their soil. So for that, and another thing is how the gravity, it encounters the gravity there. So for that, the impactor, normally one type of mission is impactor. Another one is sample return. Once we land there, then robotic way, we can again come to the moon orbit with the collection of the samples, either rocks or some soil, and those things we collect from a particular place, then come back to the so that is the sample return mission. That sample is getting collected at the moon surface and coming back to the Earth. Then manned mission. This is the final one where we do the crew landing. As I told you earlier, till now, world globally 6 missions has been happened for this manned mission. Actually 7 has happened, but apart from that, Apollo 11 to Apollo 17, all other missions, nearly 6 missions, 12 people have landed on the moon surface. So if you see the capability wise, technical capabilities wise, we start from the slide from history, because you know, the first satellite of Earth was a Sputnik. In 1957 it was launched, and after launch itself, people, once it was successful to orbiting the Earth, then people think, why not to go to the curiosity wise, moon is the nearest, every day we see the moon. So scientists thought, okay, we should go to the moon now. So in 58, 59, just in 1 year, people have planned many missions to go. So their objective was not to go there, just to go and even hit the moon and do some impact there. So just go and touch the moon. So that way, some Pioneer 0 to Pioneer 4, these 5 missions of the US, United States, and 2 missions from the Soviet Union, Russia currently, that earlier called was Soviet Union. So Soviet Union carried out the 2 missions, Luna E and Luna 1, in 58-59 time frame, and you will be astonished to know that even we were not able to hit the moon during these all 7 missions. So they have missed the moon. They were either in between itself, the mission has got aborted, or not reached at that place, or somewhere missed the moon. So 7 missions were failed. Then Luna 2 was the first mission which has impacted on the moon in 1959. This is the Russian mission. Luna means Russian missions. and Pioneer or Apollo or John, these all are US missions. So after the first impact in 1959, then Luna 9, then again failure has come, so many failure has come for both, for going for the orbiter there or as a landing, soft landing. Soft landing means if you land at a place, then such that after landing, the instruments should able to generate the power. Your spacecraft lander should be able to generate the power. And if some rover is there, it should come out, then do its experiment. So that is called the soft landing, means there is no harm in the lander. And for what it has been planned, for that it is doing. And there is no breakage in the legs or any other components. So that is the soft landing we call. So after the Luna 9, the first soft landing on the moon has happened by Russians in 1966. And you will be also surprised, like India, we have sent orbiter first in our Chandrayaan-1 mission to the moon. But lander later. In 2019, we have tried first time in Chandrayaan-2. So, but the worldwide, if you see, landing has happened first, soft landing, and then orbiter in the next, later in that year itself. Probably that landing has happened in August, and this has happened in the November or December time frame. This orbiter to the moon has gone there to collect the data. So nice pictures has been sent by this orbiter. And after that, the first human, once we landed softly there, globally people think, okay, well, we have landed, so we can send the person also there. So NASA was, US was successful in sending the first human, Neil Armstrong, to the moon surface through Apollo 11 mission, and in 1969 itself. And after that, I told you, next 6 missions, they have 5 other missions, they have sent the persons there. But if you see the launches to the moon, most of the launches has happened in 1960s and 70s. After that, there was no launch. Once moon has person has landed there, so after 1972, the last person landed there. So there was not much enthusiastic the public or scientists for science point of view. There was a null period in the moon exploration. Then in 1990s, that is 1994, Clementine mission was sent by the, it was an orbiter sent to the moon's orbit by the US NASA people. And then we have got lot of data that 100-meter spatial resolution, any object of the 100-meter is getting identified by one of the camera there. Then the payloads are there, and then laser ranging payloads are also there. That has given some 3 lakh points of the moon surface, so that can give you the height at the moon surface. So very coarse, but first time we have got some actual height of the moon surface from the laser sensor, and from those things created a lot of enthusiasm again for the public too, since the lot of information was available through those images of the Clementine and the data sets whatever received. So then again in 2007, Selene and Chang'e, 2 missions, Selene from the JAXA, which has given the nearly 10-meter type of resolution camera there, plus some hyperspectral imagers was there. Then Chang'e 1 was also in the same time frame, was launched by China. So these 2 missions gone, and these 2 also provided a lot of data sets. In 2008, India has launched Chandrayaan-1 and started its moon mission. We have started quite late, but later we speed up, and now we have reached at the level where the other people are. You can see here the country-wise different 6 different segments: flyby, orbit, impactor, lander, rover, return, and sample return and crewed landing. What is the position? Currently, United States have done all the things. Yeah.
Sir, your slide is not visible. Can you share it again, sir?
It is not changing. No, I have not gone to the next slide.
No, it's not visible. I think
Not visible?
someone
One
message.
minute.
Yeah.
Stop sharing.
Now it's visible, sir.
Now visible?
Yes, sir. Yes, sir.
Okay. So, sorry, this you can see the United States have done all the segment they have completed up to crew landing. Soviet Union also up to sample return has done. China also have done the sample return. India up to lander and rover we have completed. Next mission is our sample return mission. Then JAXA also somewhat they have the lander and micro rover they were able to place at the moon surface. But none other than these 5 countries have gone up to the lander level itself. So we are quite ahead. And if you see the recent missions after Chandrayaan 3, what has happened up to till now is SLIM, that is a smart lander for investigating moon by the JAXA. It has worked for only 2 days, not completed all the objectives, even landing slightly tilted. And but still the mission has given some data sets through its micro rover. That is the our small mouse computer mouse type of rover they sent that has got ejected from 10 meter itself when the lander was, and it has given few images. So that way we consider this mission is successful. Then Chang'e 6, that is a sample return mission, has been done by Chinese people from the near side. From the far side, they have collected the sample return, and that was the only China is the only country which has collected from the far side. Then Firefly, one of the private company, they have also landed successfully, but IM-1 and IM-2 was crash landed. Then iSpace Resilience Haikutu R of the Japan, that has also crash landed, failed. Then Artemis 2, where the crew had gone there and just taken a flyby of the moon and then came back of the NASA, this mission. This was a successful mission, and NASA is trying to again send the man or women to the moon surface. So this is the total global scenario of the landing missions. You can see most of the landers has happened in the equatorial region, while India has landed near to the South Pole, so South Polar Hemisphere. And China is the only country far side. People call it dark side, but that is not the correct word. Since moon is tidally locked with the earth, so we see always one face of the moon only. Maximum 55 to 58% area of the moon we were able to see, but rest 42%, the opposite side of the area, you can see the right image of this, that we were not able to see. So landing there is very crucial, very difficult, because you required a communication satellite there to just communicate with the orbit, because it is not in line of sight to the ground, to the earth. So, but China has done twice. One, they have put the lander rover in Chang'e 4, and then they have taken back the sample for in Chang'e 6. So 2 missions has been done, and these are the milestones completed by different countries, and nearly 40% of the missions are only successful till date in case of landing. So now coming to our own planetary missions, we have, as I told you, 2008, we have started late, launched with the Chandrayaan-1 mission, and then gone for Mars mission in 2013. Then 2015 AstroSat mission to just do the astronomical observations in different electromagnetic spectrum region. Then Chandrayaan-2 in 2019. Then Chandrayaan-3 in 2023, and Aditya also in the same year. So these are the, I will come few of them, all the moon missions in the next slides. So future, we are planning to have a Venus orbiter mission just within 2 to 3 years from now, 2 years. Then Chandrayaan-4 mission, that is a sample return mission. Then LUPEX and Chandrayaan-5 mission, and then Mars landing mission. So these are the missions in future we are planning. So coming to Chandrayaan-1 mission, the main objective was, first time we were going, so we should know the surface there, to study the surface. So we know the topography, means the height, there at different places on the moon surface, what type of morphological objects are there, like some crater, boulder, then riles, some geological features and other things, then chemical properties, what type of sodium, potassium, those things are there or not, their study of that. Then mineralogical mapping through the remote sensing observations in X-ray, visible, infrared, and microwave regions. So these type of sensors has been sent, payloads have been sent for observations related to the different type of experiment. So this is the one of the example, the terrain mapping camera we are having. It gives the 3 images of the same object from the moon surface, same area. So those, like we have 2 eyes, from the 2 eyes we are able to visualize the stereoscopic vision that gives us the perception of depth and height of an object. So that's why we are able to see the what we are saying day to day. We are seeing that the depth and height of different or size of the different object through our 2 eyes, through stereoscopic vision. So similar way here, the concept was to put 3 because we are going to the moon. There are uncertainty, so we put 3 cameras. For redundancy, 2 cameras is enough for generating the height, but 3 cameras certainly provides some more information. Suppose here we have the global positioning system. Through that, we used to give the find location of an object, but there it was not possible. So it was thought that one more camera adding and looking just nadir below, and 2 cameras with plus minus 25-degree angles. If you take image and then generate the elevation model, you can get a good accurate digital elevation model. The height points are called the digital elevation model. So this TMC camera gives the images at 5 meter, and finally digital elevation model has been generated at 10 meter interval. Similarly, we have one MQ, and here we have total 11 instruments. Out of that 11 instruments, 6 instruments was global contribution by different other countries than India. And from NASA, ISA, several other countries has given the contribution. Why these collaborations are required? Because we were going the first time, so we don't know so many things there, so many uncertainty there. So you can get the knowledge who has gone there earlier or sent some mission earlier. They will guide you such that you never fails. So that guidance came also very wealthy in case of the Chandrayaan-1 mission, and we have reached to the moon, and finally done lot of findings there through those instruments. You can see here what I was talking, Chandrayaan-1 TMC, terrain mapping camera. It has given the height first time. You can see here the height, what is the height there, moon. Moon normally minus 10 kilometer to plus 9 kilometer type of height range is available. Means if you see the Everest, deeper than the Everest and as high as it is near to the Everest. So that type of height differences are there. You can see here, these are the craters, whatever depressions you are seeing in the image. And the major finding was distribution of surface ice or water molecules on the moon surface. That MQ, Moon Meteorological Mapper, one of the camera, plus one CHASE, another instrument, and third instrument is MINISA. These 3 instruments provided the information that on the moon surface, south polar region and north polar region, south polar region, much surface ice is there in the cold traps, and where the sun is not reaching due to the depth of there and sun and those surface feature geometry is there. So always it remains dark, and those dark places there are water ice, lot of water ice or is present there, and water molecules are also been found at several other places. So that was one of the major invention of this century, you can say, that century you can say. So 21st century, one of the major invention was to finding the moon, finding the water molecules or water ice on the moon surface. So you can see those are the outputs. If you go over the moon, how it looks like, what type of depressions are there or craters are there. So this type of visualizations are possible. So this guided us for the next mission for the landing. So another instrument there was Moon Impact Probe. What it was thought, when you are going to the moon, there should be something, since we are sending the orbiter, so it will remain in orbit on the moon surface, nothing will go, but our flag should go on the moon surface. So thinking that, uh, 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 one Moon Impact Probe was designed, and it contains a camera and altimeter for giving the height when the camera takes the photograph. And then it has been placed with the orbiter, and from 100-kilometer orbit, it has been thrown there towards the moon surface. And it was not power descent type of thing. It was just free fall from there. So it was rotating, having a spin with that, and giving the photographs. So it has given nearly 3,000 photographs from the equatorial region to where it has got on the moon surface and then crashed there. So those images were quite helpful in designing how the path it has taken, then what type of gravity it has encountered at different heights. So those informations came from this. So, and that is the basis of the moon landing. So basis of the moon landing has placed in Chandrayaan-1 itself. Then next mission was Chandrayaan-2. Chandrayaan-2 contains an orbiter, a lander, and inside the lander there was a rover. So main concept was to land safe and soft landing at the moon surface. And then we have orbiter having the some 8 instruments there. And why 8 instrument has been placed? Most of the instrument was repeat of Chandrayaan-1, because Chandrayaan-1 lasted for 9 months, while it was built for 2 years to get completed all the observation, but it was not got completed due to the some problem with the Chandrayaan-1 mission in 9 months itself. So Chandrayaan-2 mission, those instrument was there. TMC, HIC has been improved at IIRS. That is, the spectral region has been increased. And then SAR, dual frequency SAR has been placed in place of NASA mini SAR. We have our own indigenous dual frequency DFSAR has been placed. Several other instrument, class instrument, other instrument has been placed for whatever objective of the Chandrayaan-1 to fulfill that only the Chandrayaan-2. But main objective was to land, and then rover has to roll down there. When we land, what happens? We can land 2 ways. Either you identify one place on the moon surface, and your system should go and land at a larger area. If you see the aircraft landing, you required some 2 to 3 kilometer length of the your runway. So that type of flat place is not available on the moon surface. Everywhere you will find some craters of different sizes or boulder. So it was very difficult. So autonomous landing requires larger area, and larger area was not there. So another thing was hazard map based. Suppose you have a camera which gives you that in the path from where you are going to land, all the images, and it tells you that these are the having the hazard region. I mean, there are boulders, there are craters, and this is the safe area where you can land. So hazard map based. So we have selected this for landing because it requires. And another next one is very precise instrumentation system you should have, so that it correct at the last moment also. Like you have lidar system, flash lidar system, or you have some Doppler velocity meter or those things. So those things was not available because of the power and weight, and this cost much more. So that's why we have gone for the second option, that is hazard map based option for the landing. So if you see the orbiter has provided lot of images till also it is working till today. So it is providing lot of data sets of the moon. That is the so many things in the world based you can tell till today. Like orbiter high resolution camera, we were having one camera which gives us 25 centimeter spatial resolution, means anything on the moon surface, it is measures 25 centimeter of length and breadth. We will be able to identify those objects through this camera. So this is very helpful in the landing. When we land, we gather the data before the landing, then characterize it, and then we go for the landing. So that way, this is the best resolution available today. The second best is NASA, that is the 60 centimeters. So better than twice it is currently, we have the orbiter high resolution camera. Then TMC-2. TMC-2 is the first instrument which has provided TMC-1 and TMC-2, which has provided the best surface DEM at 5 meter resolution of the moon surface. Currently, whatever the best is available is 30 meter from the laser orbiter, lunar orbiter laser altimeter of the NASA. So 30 to 5 meter, you can see what type of difference we have. Then hyperspectral, whatever the earlier have been flown, it was up to 3 micrometer range. And currently, this IIRS, imaging infrared sensor, is having the wavelength region 0.8 to 5 micrometer. So much more. Whatever the MQ, which has identified the water molecule nearly having the up to the 3 micrometer only. So it has been increased, and today it is the best spectral resolution available so far. And L and S band dual frequency radar, that is a unique radar. Even for Earth, this dual frequency observations were not available. For the moon, this has given. Now only it is available through our NISAR, NASA ISRO synthetic aperture radar for the Earth surface. And this L and S dual SAR is working since 2019 on the moon surface and giving the images of the moon. So that was the orbiter. That is a very successful orbiter. Currently, it is also working and giving data. Now coming to the landing portion. Landing portion, for landing anything on the moon or any place, you require 3 things to know. One thing is velocity. That is the horizontal velocity or vertical velocity or radial velocity. So that velocity is very important to know to the system. What is the velocity when it has got separated, it is coming to land? What is the velocity at different point of time? Then altitude, height of the lander from the surface of the moon. So what height it is currently. Then position, where what is the latitude, longitude, or the position on the trajectory where what we have designed for landing. So here we have some laser-induced reference accelerometer package, which provides with the star sensor information, earlier stored information. It provides us the latitude, longitude in inertial frames. So gives the position, and we call the rough braking phase. So it is coming to the rough braking phase, and there we have some horizontal velocity camera, which gives the horizontal velocity. Then lander position detection camera, which gives the position of the lander. Then one thing is Kara radar altimeter, that is the altimeter height it gives. And then LASA is laser altimeter. So 2 altimeters, because height is very crucial, and 2 different principles. One works, Kara works in the microwave region, RF region, while LASA works in the optical region, laser sensor. So out of that, one at least should work. So that was the concept. And those are the absolute instruments, absolute information instrument on the lander. So when it came to 7.4 kilometer, it is called retargeting phase or attitude hold phase, where this whole system, whole lander has to get rotated and the camera has to see the Earth surface, moon surface, and then provide those camera information and get the where the lander is, the lander position. So when this has been done, there was some problem, and in the retargeting phase, when it has gone up to 2.1 kilometer before the fine braking phase. So fine braking phase itself, the problem occurred during the retargeting. And then up to 2.1 kilometer, you can see in this plot itself, the lander has fallen down on the moon surface and got crashed. Where it has crashed, since we have placed the data, whatever there for the matching and landing, our landing site dimension was 300 meter by 300 meter, but it has crashed nearly 482 meter before the landing point. So nearly 500 meter before the landing point, it crashed. And you can see here, there are legs of the lander. It is seen there. Legs have been thrown away one place, and most of the things have been different places it is lying. So that way it has got crashed. So mission was not completed as far landing and rover is concerned. Then what was the main thing we have got? What we learned from Chandrayaan 2 mission? What are the things got successful? What has not got successful? So the achievement wise, the launch was successful, and a spacecraft was put in the precise orbit. Then all maneuvers for 17 days was very precisely done. Then it has been put on the lunar trans injection orbit. Then those path it has gone correctly. Then it has gone in the moon's gravity, and finally moon's gravity, orbiter and lander separated also. Then deorbit, and finally at the when it has to land there 2.1 kilometer above the surface, the problem came during the fine braking phase, and then it was not got completed. But our orbiters are still working, and you can see here these mosaics has been created from terrain mapping camera. Then these are the mosaics from the dual frequency SAR, and these are the class elemental composition of the aluminum and magnesium on the moon polar areas. And major thing is our OHRC, what I was talking, it is giving 25 centimeter. You can see here the Apollo 11 landing, where which vehicle he has gone there. So they left there this, and so it has been captured. You can see the actual photograph taken by this fellow, and you can see here it is lying there. Even the flag pole is also visible there, and then the astronaut paths are also visible there. So you can see there each and every boulders or craters on the moon surface up to 25 centimeters. So that was one of the achievement of this mission. So after the crash of this, there was a committee formed for the failure analysis, and lander. It was found that if we had a large area for landing, that time it was only 300 meter by 300 meter. Our landing site was so if it was bigger, then probably we might have done some contingency operation and we might have landed successfully. So first thing was to increase the landing area, landing site dimension. So it has been increased to 4 by 2.4 kilometer, keeping all the dispersions of the different cameras or different altitude, orbit, everything into consideration, increase the landing site area. And then characterize those things through our OHRC, and finally one place has been identified, the center of the this map. This is called the hazard map of that area, has been created. However, the red things are there, those are hazards for the lander. Those places we should not land, and where the green places are there only we should land. So such type of 3,900 square boxes of 24 meter by 24 meter area was present in this hazard map to land. And everywhere, anywhere, if the lander comes, suppose in the beginning also it comes, it is having, if it travels, if 10 to 20 meter, at least 124 meter by 24 meter safe grid, it will find. Such type of logic was inbuilt in the onboard system. So that way we go on ahead with this. And this was not having any orbiter. This was having a propulsion system which takes the lander into the moon's orbit. Then during the landing, this is the trajectory which has been followed. And here one LDV sensor, lunar Doppler velocity meter, was also developed in the meantime and placed there for the velocity. Earlier only horizontal velocity camera was there for the horizontal velocity, and there was no option for the another velocity. Only LEADAP was inertial system. We find some velocity component, and then both were compared. But now the LDV has been placed for getting the horizontal velocity, also some redundancy to the horizontal velocity. So it has started landing from here 1 point with the, you see the velocity there when it has started 1.68 kilometer per second. This velocity is nearly 10 times higher than whatever the aircraft velocity is. This is nearly 6,000 kilometer per hour. This velocity, it has started landing, and from there it has slightly reduced, and finally when we are going to land, this should be near to zero, within a meter per second. So that type of velocity decrease you have to do during the landing time. And at 7.4 kilometers through the rough braking phase it came, and then retargeting phase here already include sensors, get the height, get the velocity. We go for the fine braking phase. So fine braking phase, we applied those things, and then coming to the final terminal descent phase. Up to 800 meter it came, and then 800 meter, it has just hover for a few seconds to just do its orientation correct to the all orientation of the lander leg towards the surface of the moon. So you can see here the lander leg orientation. Now you can see here it is a vertical to the lander to the surface of the moon. So finally, going to 100 up to 100 meter, it has gone, and from there, there was camera called lunar hazard detection and avoidance camera. So this is the optical camera. So what we have done, we have stored the downrange images, full images there, not full images, feature points, because you cannot upload this type of, only we have on board only 2 GB of space. So 2 gigabits of space you can not load. So we have put some feature points. 86,000 feature points of this whole entire area has been placed there. And from the image, we have got some 300 points it was targeted to get, and those has to be matched with those 86,000 landmarks. And finally, finding the down that if it is safe or not. If it is safer, it has to land there. If it is not safer, then image itself, it has to find the safer area, and wherever is the safer area on the map, then it has to travel that much and travel up to 100 meter and find the safe area to land. So whatever the nearest 24 meter by 24 meter grid, it is going to land. So here there is no redundancy for lander hazard detection and avoidance camera. Each and everything having the redundancy, but hazard detection and avoidance, the last mile from 100 meter to touchdown, there was no, except for this, there was nothing in the system which can tell you that there are hazards, you should not go, you should go to other place. So these are the sensors. You can see, I already told laser and RF based altimeter, same as Chandrayaan-2. Then we have Doppler velocity meter, a lander horizontal velocity camera for velocities. Then inertial measurement using gyros and LPDC for the position. Then propulsion system, engines was there, 800 Newton throttle liquid engines, 4 was there. So then NGC software and all things has to be done by onboard computer itself. You should not do anything from the ground. There was no system that, because there is delay of nearly 1 to 2 seconds from ground to the commanding to the spacecraft. So within a second, it can move up to any place. So that's why it was fully thing has been stored in the onboard computer, and automatic landing sequence was activated. And finally, this one camera was there, lander hazard detection camera. Then lander leg was also very important. How it is going to touch there, what type of stability there, those all things have been tested thoroughly. And you can see there was question when in the failure analysis committee that is it so that if we are going to the South Polar area, that's why South Polar people think it is a much hazardous area where lot of hazards are there. So due to that, it may occur that this time also we may fail. So I have to give a presentation that in comparison to other sites, like other global missions, like Chang'e mission of the China or Apollo missions where people have landed, we have quite better area, having less, you can see here, less number of craters and boulders are there, and a very smooth surface to land. So better area, depending on our lander requirement, because lander is only having height clearance of 32 centimeter. Anything bigger than 32 centimeter is having hazard for lander, because their LAM engines, whatever throttle engines are there, that is just above the ground at 35 centimeters. So it should not go and hit those engines. So these are the few photographs of the different cameras. Whatever images you have got from 5 p.m. that day to after up to the landing, nearly 6-4 hours, 6-4 p.m. So this is the lander imager camera images. 4 cameras was there. From that we were receiving the data and transmitting to you. then rover imager, that is the rover it is, then lander position detection camera for detecting the position of the lander, then hazard detection avoidance camera. 2 camera has been placed so that if one cannot work, the other one work, because there was no other sensor, only hazard detection avoidance camera was only there. So that's why 2 has been placed there. And this is the altimeter, carbon radar, similarly laser altimeter was also placed, and this is the onboard computer system for the SDA processors has been placed there. So this type of schematic was there. You see, like we are landing our aircraft, we have some lengthwise. So here we have put something nearly 32 kilometer by 10 kilometer, 32 kilometer in length and 10 kilometer type of width of the area. All feature points have been stored on board, not the image, because image storing itself may go a lot of more than 10 GB. We have a space up to 2 gigabits only. So it was launched, and it was think that this yellow thing will come in the actual term. This was targeted based on the simulations that, okay, at 7.5 kilometer, when the retargeting phase will start, these frames should come. These 3 images will come. So if you see, this is the downward bottom image. This has actually happened. What happened? You see below this, these are the frames it came. We have given time of the 10 per image processing time, 10 seconds per image. So 50 seconds have been allotted. But here the processing has happened on 5 to 6 seconds only. So finally we have got 7 images and 6 outputs we have got of the position, and that has been provided to the NGC. So this way, this has exactly whatever we wanted, we have got. Only 200 to 300 meter difference was there in the position, and it has been provided. But the algorithm, you can see the what type of differences there at the time of imaging. Suppose these 2 objects are same in the 2 images side by side, but from the eye also you will be not identify these 2 are same, but your system has to identify. So we put some criteria that if the sun elevation is within, it should be within 5 to 9 degree of the elevation, because whatever image we have stored is of that nature. And the azimuth wise, like sun, if you see, you are taking the image in the morning, noon time, then afternoon, shadow moves anyway. So that way we provided that we required the sun azimuth when sun moved from 35 degree to 75 degree. This 40 degree of the flexi azimuth angles we kept. This is the crucial thing, that was the hazard detection avoidance algorithm. What has worked at the nearly 100 meter from the moon surface, 150 meter from the moon surface it has worked, and it has taken the image. You can see this is the LHD DAC image has been taken. This is the reference image has been placed there, feature points from this, and those are the blue dots are the features collected from this, and then finding the corners of all 4, then finding the position of this lander. Where is the lander? Then once we find the position of the lander in latitude, longitude, we find the downward, it is green or red. If it is green, then find it out what is the safe grid, 24 meter by 24 meter it is available. If it is available, you give that area. So see, this is actually happen, actual performance like this. This image has been taken. So it was matching with this bigger area, 4 by 2.4 kilometer this place. And finally telling that, okay, these are the places you have to land. So we have started landing from the 150 meter to that place, and 6 meter type of deviation we find during the landing. So nearly very accurate, precisely we were able to land at the moon surface. You know, these all things do not comes in a day, because we have to do a lot of testing on the ground. And these are the few photographs of the testing, how the lander different instruments has been tested. So one test was through the cranes. So one system has been prepared, and one crane has been borrowed for nearly 100 meter crane. This height is 100 meter. So 100 meter crane it has been put, and simultaneously for entire week the observation has been made throughout the day. Total in a daytime we take some 24 to 25 observations in different half an hour or 20 minutes time frame. We take the observations, then match on board and see that results are matching or not. Even if we are getting 1 out of 24, one failure, we find it out why it has failed, what was the cause, then again correct it, then again do the same, repeat the experiment. So last 3 days we have got out 24 out of 24 times. So we have got the correct results. Then we have frozen this system, and then we flown on the this one drone also. And this drone, we flown that and getting the results correctly or not. Then helicopter also has been flown at the Chitradurga area in Karnataka. There we have a lunar simulated region. The lunar like boulders and craters has been placed. 20-meter diameter type of craters has been made there in the nearly 2.5 kilometer by 1.5 kilometer type of area in Chitradurga it has created. So a lot of 19 craters, big craters are there. So there we flown the helicopter, and all instruments has been tested. And finally at SAR, hovering test at 100 meter has been done. There is a tower crane already placed there. So there we have also generated some 50 meter by 50 meter area lunar-like terrain we have created there, and then done the test. First the passive mode, and next one was after firing of the engine. With firing of the engine, how it performs, the other sensors. Is there any problem when we fire the engine? Something is coming in our camera field of view, or any instrument field of view, or our height is getting affected by those. So those tests has been extensively carried out at the Sriharikota, and finally all tests have passed and then flown. So a lot of testing has been done this time. Then these are the few photographs. This is the one of the video where this our orbiter and this propulsion system whole Chandrayaan 3 module are going to insert into the moon's gravity. That lunar
Amitabh says, sorry to interrupt.
So that is the first image of that. Second image, it was hovering at 800 meter and telling that, okay, I am fine, I am going on the right. No.
It's already 6 o'clock, sir.
Okay, so we will wrap up, no problem. Just so these are the few photographs. So this is the OHRC camera, which tells that, okay, here is the lander, it has landed successfully. Then these are the deployment of the rover ramp deployment, then solar panel opening, then rover roll down. So these things, then rover has moved also based on the two cameras placed in front of the rover. Two cameras are there, navigational camera, which gives us the height at the moon surface, and rover has to roll down. So rover whatever moves or sets. So total rover has moved up to 101 meter. You can see here currently the Vikram lander is parked here and Pragyan rover is here. So all 14 days mission was there. So when 14 days is completed, this mission has got finished. So currently you can see these are the impressions on the moon surface of the lander and rover. So these are the few, we are giving some data sets to our foreign different countries, and this is the one of them we have given to Japanese mission. Then this is the SLIM we have supported for their landing. Then this is the Chang'e 6 site, first imaging by our TMC itself after 5 days of landing. Then future missions, Venus. Venus, we are going to do the atmospheric studies mainly, because Venus is full of the cloud. So different type of sensors, 12 sensors has been planted there. One is thermal camera, one is ultraviolet VCMC, Venus cloud monitoring camera, which will monitor the cloud velocity and cloud composition at the moon, Venus mission. So optical cameras cannot see the Venus surface. So we have put the VSAR, that is the Venus synthetic aperture radar. In a stereo mode we are going to operate, and we are going to have the height of the Venus surface also. So there are several more instruments to know, different X-ray instruments are there, which are going to gather the information about the Venus. So next mission is that. Another one is sample return mission, Chandrayaan 4, where you can see this only safe and soft landing currently we have, but other 4 things, whatever Elo highlighted currently, we don't have. That is a sample collection and how it should put in the container. Then ascent from the moon surface. Currently descent we have, ascent we don't have. But Hope experiment we have done in the Chandrayaan 3 time for nearly 1 minute, and so that with that information we are going to ascent. Then docking and undocking in the lunar orbit, then transfer of sample to one module to another module, then re-entry into the Earth orbit. The major challenges here are the sample dual launch architecture, because this whole stack of this is getting more than 74 and 7.5 ton, and our capability currently is 4.5 ton through our GSLV Mark 3, LBM 3. So two different launches. So dual launch is there. Two different launches. It will happen, go in the Earth's elliptical orbit, then stack it, and finally those full stack will go to the moon's orbit. Then again, so this docking and undocking is always a challenge for this mission. Then two launches are also challenge. Then transfer of the data sets, whatever samples from ascent module to reentry module, and finally re-entry into the Earth's surface. So those are the challenges there. This is a very challenging mission, and in near future we are going to do that. This is the site has been identified. This is the Mons Mountain area in the near to South Pole, 85 degrees south latitude. This is the area you can see there. This is in fact a plateau, 6 kilometer above the nearby surface of the moon. So this type of plateau, this is the plateau in fact, and here we are going to land. Another mission is Chandrayaan 5. Here exactly on the pole we are going to land, that 89.4 degree. If you know, tomorrow Chang'e 7 is going to be launched by China, and it is going to land somewhere on this crater rim. So crater rim is quite dangerous, but it is going to land here. So our landing place is currently here. We are going to land at this site. This is very challenging. And why we are going to land this? These cyan color things, you can see these are the water ice or water hydroxy molecules are present in these traps. So if I land here, we can go nearly 200, 300 meter travel. We can go there, and then those objects will be analyzed by the different instrument available on the this surface. So illumination is one of the shadow illumination. Those things are quite critical here. Very less landing area. We have nearly 10 meter by 10 meter type of landing area is available here. Not 24 meter by 24 meter, and even 4 by 2.4 kilometer. We were talking earlier. Now you can see 50 meter by 50 meter area itself is getting is quite difficult in these regions. So those are the challenges in these missions, and all the data sets, whatever I have shown, or otherwise data sets, if you want to do some experimentation to gather some more knowledge, you can go to our site www.issdc.gov.in, and all the data sets are available there. Even we are members. India is a member of International Planetary Data Alliance, where all other spacefaring nations are the member. So there also their data sets, they can access from our site, we can access from their site. So you can download and do the experimentation. Thank you. This is the team of Chandrayaan 3.
Yes, sir. Thank you, sir. Actually, we would have introduction of Amitabh, sir, in the beginning itself, but due to some technical issues at her place, it didn't happen. So now I'm inviting Sanvi from Creactive to introduce our resource person, Mr. Amitabh, sir. Sanvi, over to you.
Good
Sanvi.
evening, everyone. Yes, ma'am.
Continue.
Good evening, everyone, and a very warm welcome to our another special session of the Creative Weekend Talk, organized on the occasion of the National Space Day 2026. My name is Sanvi, studying in Class 8, Vidyanidhi Public School, and I am proud to be a member of Creative team. It's my privilege to introduce our distinguished speaker for today, Mr. Amitabh, scientist and engineer SG, and head of the Planetary and Space Science Data Processing Divisions PSPD Space Application Center, ISRO, Ahmedabad. Mr. Amitabh holds an MSc in Electronics and an MTech in Remote Sensing from Birla Institute of Technology, Mesar, Ranchi. He has been associated with ISRO for more than 23 years and has made significant contribution to satellite image processing, remote sensing, computer vision, satellite photogrammetry, digital cartography, and planetary data processing. He has played important roles in several prestigious ISRO missions, including Chandrayana 1, Chandrayana 2, and Chandrayana 3. His major contribution to Chandrayana 3 include the identification of landing sites and the development of an computer vision based hazard detection and avoidance system for the safe landing of the lander and traverser of Pragyan rover. He has also served as project director and operations director for Chandrayana 2 and Chandrayana 3 and has contributed to the processing of data from Cartosat and other satellite missions. For his outstanding contribution, he has received several honors, including the Young Scientist Award in 2008, the Laureus for the Team Achievement Award 2024 from the International Academy of the Astronautics, and the Rashtriya Vijnana Team Award 2024 for the ISRO Chandrayana 3 team. Today, we are truly fortunate to have such an accomplished ISRO scientist with us to share his knowledge and experience with us on this special occasion of National Space Day. On behalf of Creactive, I warmly welcome Mr. Amitabh sir and all the participants joining us today. Thank you.
Thank you, Sanvi. Now we are having questions for audience regarding first session. I'll read the questions out and it is also displaying on the screen. Please note it down and send your answers to the number shared in the beginning. We'll also display the number once at the end. Question number 1. Question number 1. Hazard detection and avoidance system of Chandrayaan 3 was used in the following stage. Option A, rough braking phase, attitude hold phase, fine braking phase, hovering phase. Question number 2, which instrument is going to be used for detection of cloud velocity in the Venus orbiter mission? Question number 2, ma'am, can you share the question number 2? Yes, here it is. The question number 2 is, which instrument is going to be used for detection of cloud velocity in Venus orbiter mission? Option A is RAVI, B is VISPER, C is VSAR, and D is VCMC. Please send your answers after completion of second session. So now, a heartfelt and special thanks to our esteemed resource person, Mr. Amitabh sir. We are deeply indebted to you for taking time out of your busy schedule to take to grace our virtual platform. Your profound knowledge, engaging presentation, and the practical insights on a Chandrayaan 1, Chandrayaan 2, and Chandrayaan 3, and the future missions have immensely enlightened our minds. Thank you, sir. Now we are moving forward to our second
Thank you.
session.
Thank you,
Yes.
sir.
So I can disconnect.
Yes, sir. Yes, sir.
No problem. Okay. Thank you. Thank you.
Thank you, sir.
Thank you, sir.
Uma, you can
Okay.
hand over to Madhuri.
Yes, ma'am. Okay, now we are moving forward to our second session. It will handled by Madhuri from Creactive. Over to you, Madhuri.
Thank you, Uma. And now, let's continue our exciting journey into the world of space science. We have already completed our first fascinating session on interplanetary missions of ISRO. A big thank you once again to Shri Amitabh, scientist, ISRO Ahmedabad, for taking us on inspiring journey through India's interplanetary mission. But our journey doesn't end here. We are now ready for the second session of today's National Space Day 2026 Twin Talks. Our next session is titled Planet Platforms for Planetary Missions. To introduce our esteemed resource person for this session, we are happy to have with us Raghavi, a creative volunteer. Raghavi, we invite you to introduce our distinguished guest, Dr. Sharma Rao, scientist, ISRO, Bengaluru. Raghavi, over to you.
Good evening, everyone, and a very warm welcome to another Creative Weekend Talk. My name is Raghavi, and I am a 10th standard student of Sri Sai Sadbhavana School, Bengaluru, and also a proud member of the Creative team. It is my privilege and honor to introduce our distinguished speaker, Dr. Shyam Rao, who is currently working as the Group Head of Human Research Engineering at the Human Space Flight Center, ISRO, Bengaluru. Dr. Shyam Rao completed his BE in Mechanical Engineering from NITK Surathkal in 2000. He later pursued his MTech in Machine Design and PhD in Planetary Rovers from IIT Madras. He has made significant contributions to India's planetary exploration programs. He served as the project manager for the mechanisms of Pragyan, the rover of the Chandrayaan 3 mission, which successfully achieved India's historic soft landing on the moon. His outstanding contributions to space technology were recognized with the ISRO's Young Scientist Merit Award in 2010. He was also a part of the team that was granted a patent in 2014 for a method for manufacture of highland lunar soil simulant. His areas of research and expertise include spacecraft mechanisms, planetary rovers, electromechanical systems, and human factors for space habitats. His work beautifully connects mechanical engineering, space science, and the future of human space exploration. We are truly honored to have such an accomplished ISRO scientist and space technology expert with us today. On behalf of Creative Knowledge Square, sharing knowledge increases our knowledge. I extend a very warm welcome to Dr. Shyam Rao. Sir, we are delighted to have you with us. We look forward to learning from your experience, knowledge, and inspiring journey in India's space program. Over to you, sir.
Okay, thank you for Raghavi for nice.
Sir, just a minute, sir. We have an announcement. Before we begin this second session, I have an exciting announcement for our participants. Dear participants, listen carefully because there is an exciting opportunity waiting for you today. After this session, we will have a question and answer challenge based on today's talk. And here is the exciting part. The participants who send the correct answer first to the given number will have an exciting cash prize. So make sure to listen the talk carefully, understand the concepts and stay alert. Once the question is announced, think quickly and send your answer to the given number at that time. So keep your phones ready, keep your minds active and stay alert throughout the session. You will Sorry, you never know. The next winner could be you. Thank you, Raghavi, for the wonderful introduction given to you. Sir, it is indeed a privilege and honor to have you with us today. Planetary missions are the result of years of scientific research, engineering, innovation, and teamwork. Understanding the planets behind these missions gives us a deeper appreciation of how humans explore worlds behind our own. and today we are fortunate to learn about this fascinating subject from an expert from ISRO. So, dear participants, keep your curiosity alive and get ready to explore the technology and makes planetary mission possible. Dr. Sharma Rao, sir, the virtual stage is now yours. Over to you, sir.
Okay, thank you. Madhuri, I wanted you to confirm whether I'm audible and
Yes. Sir, you are audible, sir. You can continue.
is my slide visible?
Yes, sir, it is visible.
Okay. So the participants, which like whether you heard Raghavi or Madhuri, I'm sure you might have heard Madhuri because there are exciting prizes, which is more important because the first one you would have not remember a sentence of what my introduction is. Okay, that's fine. Okay, so now I would like to take you because you had a very like detailed and a very informative session by Amitabh sir, who like together we worked for Chandrayaan 3 mission. So during the rover which was being operated on moon, so by us, we were in the same control center. And thanks to him for making this presentation little easier. Okay, so now I'm not here to give you like very detailed technical discussion on engineering aspects. But for example, you might be having like, why do I need to study maths and why the equations are there? Why I keep making mistakes when I calculate like 3 by 4 plus another like 16 by 2 or something like that. And why am I required to do that? So then you ask your teacher. So what the teacher says is, no, these become bricks in your wall of scientific curiosity. So now, similarly, when you have heard like there were landing legs, there were cameras, and it has to land so precisely and all. So why these things are required? Like why are we doing it? Like why are you learning math, science? Okay, so some of you may not have really like get into the exploration or anything like that, but a curiosity, basic human curiosity, why it has to be done. So that I'm trying to structure basically how these missions are chosen. Like when we have first Chandrayaan 1 mission was orbiter mission. Okay. And similarly, first mission to Mangala Graha was again an orbiter. Okay. And in Chandrayaan 4, in Chandrayaan 2 and 3, we plan to land. Okay. Then in Chandrayaan 4, we want to bring back the sample. So why this is done? What is the purpose of doing such thing? Like what is the big picture here? So I am trying to give you big picture. So what happens is like when you go to say supermarket, if everything is everywhere, so it's very difficult for you to pick and choose what you want. So you will get lost. So now when you hear all the information about space mission, so you some of you might get lost. Like why are we doing such information? So I am trying to put things in different perspective so that you can appreciate these things. And once you appreciate, so you should be knowing how I can contribute, like how I'll be able to be part of such like discoveries. So let us go to this, and I recommend some of you, even though it might be like it depends on the age group you are in, but it's a very good book. It is called Planetary Exploration Horizon 2061. So this discusses like as I was telling you, you are going to a supermarket. So first is like you have the vegetable section. So then you go to another section. So this is where I am trying to categorize overarching science goals. So what are your science goals? Like why do you want to study? So have you ever wondered like why moon is such a color? Like why there are so many craters on moon? Why Mars is red? So these are like some curiosities which you develop as kid or as you grow up. So we need to understand the key science questions, basically how these were formed. So the keys that becomes the pillar number 1. So all these missions, what you have seen, are dependent on 4 pillars. So the first pillar is key science question. So what am I asking here? What is my question? Okay. And once I have a question, for example, I want to know whether oxygen exists on the surface of Mars. So that is my question. So how do I measure? So you need to take something which can measure oxygen, or if there are any small amoeba kind of life cells existing on Mars. So how do I know like that particular this thing exists? So I take measurement requirement. So, but when you want to, for example, you want to get the X-ray done. So you need to carry the X-ray machine with you. Okay. So that is where the requirements come. Then the target types, like, am I going to moon? Am I going to Mars? Or am I going to asteroid belt? So that will dictate what kind of targets, like missions, you want to plan. For example, I cannot plan a mission to outside our solar system, because that once I have that target, then mission requirements is like I need some kind of a nuclear powered propulsion system which will take me there. So that's where I'm now. Once the mission requirements are set, so now you need to know what type of technologies are needed. Like, do I need a lander? Do I need an orbiter? Or a helicopter can I fly? Or some car I can run on these surfaces? So that is the technology aspect which we are looking at it. But like one is, that Chandrayaan was built in ISRO, but was it built in a shed, or like how the infrastructure was done, like how the control was done, how we were communicating. So you need to have infrastructure, as so many pictures were shown by Amitabh sir. So in those pictures, how these pictures were acquired, where they are stored, who can have the access. So that kind of infrastructure also has to be built along when we really want to like work on this. So it's a very expensive and it's a very serious business in terms of, even though it's a small like an information that India has landed on moon, but it was not like without all these pillars in place. Okay, hope you appreciate this aspect. Okay. Now, what are the key scientific questions? So if you see the planet, like if you want to, beyond the solar system, you want to understand how the sun works, how other stars work. So before that, let us look at our backyard itself. So you have something called terrestrial planets, like the planets which have a solid surface, like the Mercury or the Venus, Earth, Mars. Okay. Then you have asteroid belts. Then you have some gas giant planets. So then you have like very dwarf planets or very cold planets. So why this, like how these came into being? So diversity of planetary system itself, like how these came to existence. And what is the architecture, like why that particular architecture exists in those planets. So why some of them are ice giants, some of them are gaseous. So why that architecture has come into existence. So exploring the diversity. So once we know the diversity, so can we understand the diversity of like the whole star system, origin of planetary system, how the stars and planets were born? How do planetary system work? Is there any end to it? Like, does it come with an expiry date? So is there a, like where sun can get cooled totally and we don't receive any energy? So how do we know this? So these are some of the scientific questions which led to some of the discoveries. For example, if you see here, searching for inhabited planets. So what does it mean is, where the human beings can stay in some of the planets. For example, if dinosaurs knew that they are going to go extinct, so if there was one very intelligent dinosaur which has told, okay, let's hike an asteroid and go to Mars and start living there. So maybe dinosaurs would have been stayed in our solar system. So similarly, the same thing happened to humans. Look, tomorrow some, like COVID itself gave some kind of a trailer. So if something happens that, so we should know where the humans can stay. Okay, one is staying. The other one is, are there similar human beings or similar animals or similar plant system anywhere else in the solar system? So this is a very interesting questions, don't you think so? Okay. So now I know, yeah, I have so many questions. Okay, so like I want to become an engineer. So what do I do? Like how do I become an engineer? So you need to learn maths, physics, and you need to give exams. Okay, you need to build cars, you need to build maybe power plants and all. So in this, now I know I want to explore the 9 destinations which have been put here is Earth, Moon system, Venus, Mars, Mercury, gas giant system, ice giant system, small bodies, and some interstellar medium, extrasolar planetary body. That's where finally we want to visit and see, like beyond solar system, what exists. So how do I do that? So do I need to really send satellites? No. So you can have Earth-based telescopes also. In fact, in your backyard itself, you have a telescopic system, so which can measure these things which are happening. So we can have go flyby. We go very near to it, and or we can have a robotic exploration like the way we did with Pragya. So where we went around a portion of the moon and try to understand. And in sample return, you can bring back the sample because you cannot carry the whole instrument like building. Some instruments are positioned in building on Earth, so sample has to be brought back to Earth to understand, study. So that is where, like Chandrayaan-4, when it comes, you are going to bring back the lunar sample. So finally, is that the one, like as I told? So some of us believe, like some human beings believe, that we should explore other planetary bodies. Like someone left their shores and explored the 7 seas, and they found like various continents and diversity. So they were so excited. Now you have so much of connection. You can see, like if you were to be some few thousands of years or hundreds of years, you never had like imagined that there is going to be a, like there were some people staying there. So human exploration is a very natural extension of your curiosity. Okay. So the 7 type of missions I have just told, I have just tried to summarize that you want to observe from Earth or Earth orbit, or you have some meteorite which has hit. So you go and collect, like where it has come from, and you do flybys, or you go around the planet, or you do in situ exploration, or you bring the samples, and finally leading to human exploration. So is it like, okay, I have an idea that I want to go to Mars. Okay. Then no one will give you money to go to Mars unless you answer science key questions. So what questions are you answering? So are you answering the diversity of planetary system? Are you answering diversity of our system architecture? When you have gone, like I have gone and visited and told my center director or someone in your class, you told, like one of you have told that, no, sir, I want to explore gaseous system. So what are you looking for? So this is how the general system is evolved. So what questions you want to answer? Okay, fine. So you want to go, I'll give you money. So now you tell me, like what you want to do. Do you want to do an observation, or you want to go to near to that surface? So you need to spell out what specific mission you are interested in and what kind of measurements are you doing. Are the measurements feasible? Okay. Then comes, okay, now I know I have to land. So if landing on moon was so simple, then how many countries are there in this like planet Earth? So you should have had at least some 200 people landing their crafts, right? It does not happen that way. Only select few countries do it. Why do they do it? Because you need that infrastructure. So infrastructure is, you need to have enabling technologies. So you need to have instrumentation developed capability. You need to work. How do you go there? Like what kind of fuel system you need to carry, how much fuel to burn, and when you burn, like whether the landing gear is sufficient to take. You have so many cases where landers have gone, and in fact, Amitabh sir shown that some of the pictures where they crash landed. So how do I do that? I have to do a lot of technologies. So, but now the thing comes is, like, can you do it very cheap, in a cheap way? So that is where disruptive technologies come, which I will dwell at the end. So kindly remember this, there is something called disruptive technologies. Like mobile phone was a disruptive technologies. It was like like the way we interact now or communicate or consume the data has changed totally. Okay, now we need not only this, like we need infrastructure, like we need observatories, we need data crunching centers, we need space. For example, if astronaut has to land on moon, you should know, you should be able to predict when the radiation are going to hit or when some meteoroids are going to hit, so that they can protect themselves or they do not go outside. So space weather has to be known. So these are some of the pillars or infrastructure services which you need. Okay, if you see the humanity in this thing, it's like they have sent so many things, so it is not even like unimaginable unless this was put in a graph. Even though you see small pictures, so people have sent some probes, some landers, and even on the Venus also it has very high pressure. Like it will be like you are in the deep sea. That is the kind of pressure Venus has when you are still on on the surface. So your battery system won't work, and you are like within, I think Venus, Russian landers have taken the images of Venus. Hardly it lasted for few hours or few minutes. So the whole thing was over, and it had to go through sulfuric acid clouds. So now here you know that you have clouds which have water vapor molecules, but there you have sulfuric acid clouds. Do you want to like travel on a plane in Venus? You can think about it. So how it will really, the way it progresses is you do first from Earth, then you go to moon or L1 point, then you start going to interplanetary and interstellar cruise, and you go flyby, you build satellites. Either satellites can be single one or like multiple probes you can send. Like if you want to be very frugal in your designing this thing, you can send small satellites, because it is very easy to build or cheap to build small satellites. Then you take some of them out of say 10, even to make to the destination, then you have a mission. Okay, so then whether you want to have rover, travelers, balloons. In fact, if you look at NASA is building underwater like snakes kind of a thing, which will go inside some of these system where there are lakes of ammonia. Okay, so this is how the scientific mission generally are formulated. Okay, so these are some of the things which I have tried to tell. Like right now, if you have seen why people want to go to moon, is that will be a launch pad for going to Mars. So you can see some of the pictures of new missions which are being addressed. So for example, you have a dragonfly. You might have seen like some people taking beautiful wedding pictures, right? Like when some wedding is happening, so someone is flying with fancy colored drones. So you have the same opportunity on Titan, so where you can send these kind of quadcopters and take the image. And even NASA has flown, I will show that, a small helicopter to the planet of Mars. So it is called Ingenuity helicopter. Okay, so now let us look at our own Indian scenario. So I'll try to, even though some of these things were covered by our Amitabh sir, I'll try to give you with respect to how structurally to put. For example, in Chandrayaan, pillar 1, do you remember pillar 1? Pillar 1 is, what is your scientific objective? So to conduct scientific experiments using instruments for preparation of 3-dimensional atlas. So you want to understand how the surface of planet or moon is. For chemical and mineralogical mapping, you do the entire surface mapping to test. Okay, and you want to know what kind of materials exist. Does it contain magnesium, aluminum, silicon, calcium, iron, titanium? And before I want to send in Chandrayaan to a lander, so I would like to test, if I send something onto the moon surface, how it will impact, like what kind of flow happens. So we in Chandrayaan 1, there was one small impact sub-satellite which was carried out, and it is called Moon Impact Probe, so MIP. So this was sent and it crashed onto the surface of moon. Okay, now I'll give you a picture of how satellites look like. because some of you already might have seen, but I'll try to, I'll be guide for you here in terms of introducing Chandrayaan platform. So this is where pillar 2 and 3 come. 2 is basically the platform itself. So as you see, my title of my talk is Platforms for Scientific Exploration or Planetary Exploration. So what kind of platform do you build? So you build these kind of satellites. As you can see, it's a cuboidal satellite. It has solar panels. It has mini SAR. SAR is basically a small antenna for imaging. Then lot of instruments are put. You don't worry about what is MCube, LLRI and all. So when you want to design your own systems or your own telescopes or experiment, then you will study more about them. But generally, I'll give you a small brief. We had a terrain mapping camera. So basically, it mapped the surface. In fact, as Amitabh sir was telling, in fact, ISRO supported with our Chandrayaan 2 imaging, so HRC imaging, to help others to understand where they have to land and all, right? So which he has shown. So then we have hyperspectral imager, so HIC it is called. So you want to map what kind of minerals are there, so without going to the surface, so that next instruments which you are going to carry, you can narrow it down. You don't have to send an instrument which will measure all the mineralogical properties. Okay, then you have lunar laser ranging instrument, then high energy spectrometer, moon impact probe. So this is what I was talking about. So there was a small body which was sent onto the surface. You can see here, it is called MIP. Okay, so which crashed onto the surface of moon. Okay, now the pillar 4. So is it okay just if I build the satellite platform? No. If you go to Bailalu here in Bangalore, okay, so you can see this IDSN 32-meter antenna. So you cannot, like, if you are if you see your DTH satellites, they themselves will contain a small antenna, right, to receive signals from satellites. So you want to receive signals from, for example, MOM satellite, then you need to have a very big antenna. So this antenna had to be built. So that is what it is called, pillar 4. So similarly, there is actually a data center which collects all scientific science data into one place. Okay, so it is an infrastructure which is needed. Now I will put the same Mars orbiter mission into, try to put in pillar 1, pillar 2 and pillar 3. So what was the scientific question? So you wanted to see what are the surface features, morphology, mineralogy and Martian atmosphere. So this is where the question, like, what is the architecture of that that planetary body? So that was the main question which was asked. Then you built a pillar 2, measurement instruments. So measurement instruments were Mars color camera, then which basically took the pictures of Mars. Then there was alpha photometer. Okay, so it studied ratio of deuterium and hydrogen. So, and there was on thermal infrared imaging spectrometer. So it maps the surface composition and mineralogy of the planet by measuring thermal emission. See, for example, you can understand some of the minerals by measuring its thermal properties. So you don't have to take picture all the time. So there are, like, for example, if they want to know inside your bone, like, then they take X-ray. So similar to that, there are different instruments which have to be built. Okay, so I'll not go into, like, methane sensor is one. So why methane sensor? It is very interesting. For example, if there are some microbe which are existing on the surface, so they are going to generate methane. So that can be picked up to understand whether there are any living organisms there. Okay, then you have pillar 3. So pillar 3 is, we had to build this satellite, and it takes quite a minute. Like if you send one command here, so after around 30 minutes, you will come to know what has happened. So you need to build autonomy. So you cannot wait in between what will happen. So you need to have autonomy. Autonomy means it has to work on its own. Okay, so this was a very interesting technology, or the pillar 3, which was built by our Mars orbiter mission. Okay, so those were 2 planetary bodies which we were having discussion on. Okay, but as we told, we want to understand even the solar system and interstellar medium. So there were few more platforms which had to be built. So why this AstroSat was built? To understand high energy processes in binary star systems containing neutron. Okay, then estimate magnetic fields, study star birth region. So this was looking outside the solar system. So as I told, we want to understand our own solar system backyard and outside, so that we can detect like how other star systems are working. Okay, then pillar 2, it was celestial source in X-ray and optical and UV spectral band, which was studied. So the mission was pillar 3 is this AstroSat satellite, as you can see, and it was launched on PSLV C30. Okay, and you can see there was a soft X-ray telescope, large X-ray proportional counter. Okay, UVIT. This was one of the large telescope which comes from here to here. Okay, so then there were different imagers and infrastructure. So all this data which AstroSat collects, you can be found on this website. Okay. Now coming to Chandrayaan 3, I will not spend much time here because Mamitabh sir has already covered most of it. So I'll just give you like the question was again, what kind of material the moon is made of, or like are there ions, particles which are bombarding, so that astronaut goes there, so they are not hit by some radiation particles. So this is called this was plasma, ions and electrons, which was measured by using Ramba. Okay. Now you might like when you wear a coat, right, you will become very warm inside. So your temperature is protected. So if I want to like you have put a thick, uh, for example, coat, overcoat, what I'll do is if I want to understand your body temperature, I will poke with a needle. So similarly, there was one Chaste which used thermophysical experiment. So it measured the thermal properties of lunar surface, and as you go below, the temperature drops very significantly. That was the payload which was shown. In fact, Amitabh sir, if you have really paid attention, he told like we did an hopping experiment. So we moved and again landed in a small neighborhood. So this, if for example you poked, for example they have poked somewhere else, then you may not get the temperature. So we were lucky enough to have one more measurement being done and correlating at two places how the temperature of lunar surface is. Then are there any moonquakes? Does anyone know? Okay, this is what ILSA tried to find. Are there any seismic activities which are happening on the moon surface? Then I was part of rover system, as I told earlier. So we had two experiments. One was APXS, then the other was LIBS. So these were used for chemical composition and mineralogical composition, respectively. So even propulsion module also carried one more instrument. So I will show you like how this you now see. I told pillar 2 is known, but how the pillar 2 has to be, like for example, APXS you have built, but what someone the person who has designed, no, he or she tells that the APXS has to be placed just some few millimeters away from the surface. Okay, you carry something like which is few millimeters away from the earth or surface, then when you are moving the rover might get like stuck, right? So how do I do? So this is where the pillar 3 comes, wherein which I want to see what can be done so that this payload is placed the way the scientific team wants. So this is where I will show you a video. So this is called operation of alpha particle X-ray spectrometer. You can see here, this slowly moves. Okay, again it is moved back so that rover does not tip over. Okay, I'll show you for your purpose once again. See, pay attention how this is moving. Okay, so it is very important not only to have the capability to configure missions, but you should be able to do the engineering of it. That's where all the engineering thing comes from. Okay, now similarly, like recently Aditya L1 satellite was launched. So this is again to study sun. So I want to know sun, what is happening at the sun. So this particular mission was sent to L1 orbit. I do not want to complicate here and tell what is L1 orbit and why it went there. You can find out now. You have Chat GPT with at your disposal. So that is not my intention of giving you a lot of information, because nowadays information can be found by click of a button, like asking one query to Chat GPT. It will tell like Aditya L1. But you are not here for that, right? You are here to understand the basics behind it. Okay, so we wanted to observe in situ particle plaza environments, diagnostic of coronal loops, okay, development dynamics of origin. Okay, these are very big scientific questions which were needed to be understood. So there were two main telescopes which were built. It is called SUIT, then VLC. I'll run a small video here, okay, which you can understand. So I was part of one of the small, like these, if you see, it will show in the picture, like these get deployed. So it has to be covered and uncovered when they are doing some experiments. And there was one more small instrument here, which had a mechanism. So which I was part of those mechanism. Here it is L1 orbit is shown, like where you have sort of a, like, it's an imaginary point around which, like, you see all other satellites revolve around Earth, but this satellite revolves around L1 orbit, and in a very crazy and funny way. So now I'll show you the pillar 3, how it was built. So this is VLC. So this mechanism is what I have designed. Okay, you can see here. It goes, this is actual. Okay, you can see. Okay, then we had XPOSat. Like there will be some specific instruments which they want to understand. X-ray, okay, X-ray polarimeter satellite it is called. So it was a very dedicated scientific satellite to carry out research in space-based polarization measurement of X-ray emission from celestial sources. The satellite, and this was a smaller satellite which was built. So we build different satellites for different purposes to answer different questions. So for example, some of you tomorrow might become, like if you are a student population here, some of you want to understand like really some other how something works. Then you join some of these organization, Raman Research Institute or Indian Institute of Astrophysics. Then you tell, okay, I want to measure certain things. Then you give this question to ISRO. So ISRO will discuss whether really this has to be built and how it has to be built, how much it will cost, do we have sufficient understanding how to do it. So that's the process which is done. Okay, now coming to Chandrayaan-4 sample return mission. So I was part of this mission, like where landing gears are there, and there is a docking mechanism here, and there are solar panels. Okay, and there is a drill mechanism. There is a robot which collects sample and puts into a small bin. So the small bin is carried back again to the Earth. So you imagine, like you are working in a small, very remote area, and remotely something has to be pulled, and you should, because you have spent so much money, you have to make sure that it reaches Earth. So it costs a lot because you have to do a lot of testing. Okay, so it is not that easy to build something, because that total technology has to be evolved in the country, and for that we need people who are very intelligent, who really are very enthusiastic, either engineers or scientists, and the nation needs that. Okay, so this is our own, which I have summarized here. Like I started with Chandrayaan, then I told how Aditya and Astrosat and Chandrayaan 2, Chandrayaan 3, Chandrayaan 4 and all. So, but this is the overall, like if you ask NASA, this is what they'll tell they want to do. So initially they'll, like you should know the big picture, right? This particular talk is not about nitty-gritties. It is about big picture. So how, if you want, maybe right now we are here, right? We have landed, but you want, initially they have gone, but now NASA wants to take the astronaut and around the moon, right? So this is where, like when you grow up, some of you, if you are, for others, it might be an information to see. But here, for example, this is how it is being planned. Like you send first small rovers, then you send small unpressurized rovers, then you build suits so that humans survive, then you build cars for humans to go around. Then, for example, when you go to a city, if electricity is not there, you will not be able to like do anything, right? So you need to generate electricity. So, and you need to have communication. You have seen some towers on some of your buildings, right? So you need to have a communication towers. But can you work there? So you need to have plants which will use in situ material and build bricks for you, so that you can, otherwise you have to carry everything, like you carry tons of metal from here, it will be useless. So you have to, like when people were staying on the, say like ice, where a lot of snow is there, they built igloo. How they built? They used this the snow there, which was like a concrete, and they built. So you need to build with existing what systems are available. Maybe some of you can think of how to build this, or some of you, if you are interested in communication, so how do I build a communication tower on the surface of moon? These are the questions you can ask. Okay, then you need nuclear power, because for example, some permanently shadowed regions are there where sun does not reach. Then you have to have nuclear power so that you can get electricity. Okay, so maybe someday some of you might see some moon also lit up using the, like the street lamps on the moons might also light up on some day near future. Then you have to get long duration habitation, because staying other than on earth is very difficult. So you need to learn how to stay for long duration with very limited communication. Okay, so this is the, like the engineering is very exciting. So you can see on the surface of Mars, if you want to reach, so how do you reach? So there also you get basically parachutes. Okay, you can see these videos are taken using the actual cameras which were present. You can see a car like Maruti 800 kind of a car, or Alto or Punch. So that kind of car was sent to the surface of Mars. Okay, maybe some of you will be dancing in some of the centers when you grow up. And this is like how to, you have seen a lot of people flying on the, like during the marriages, right? So NASA flew it on the surface of Mars. How exciting that is. Okay, so isn't it very exciting? Now we are collecting, like we are trying to bring samples from moon surface, but NASA is planning to bring Mars from samples. So there you imagine, I'll show you the video. Okay, so there right now the rover which I had shown earlier, right, it is collecting lot of samples from the surface of Mars. Okay, those are dropped, and the next mission they'll be collected and put into a rocket. You can see this rover is loading these samples. Okay, it has taken samples from different places, and there is going to be a small lander which comes and drops. sorry. Okay. Yeah, sorry. There was some issue. Okay, so these samples will be placed on a rocket, and that rocket, like building the rocket from Earth itself is so difficult. Now imagine the same rocket has to be built on the Mars, and it has to work so perfectly. And see, you might be seeing like even catching something in the field when you go to Chinnaswamy Cricket Stadium to watch IPL. If someone drops a catch, how do you feel? So you imagine that is being done in the Mars orbit. It has been thrown and someone has to catch it, and that caught one has to be brought back to Earth. So how difficult or easy it is for your own imagination. Okay. Now what happens is that these missions are very, very costly. This is where I would like, now you might be hearing like Chat GPT, artificial intelligence, like some of like the elders are worried that what happens like if autonomy takes place, whether they lose jobs and all. So for example, similar thing exists. As I was telling, it is very costly to send something and make it operational. You need a lot of money. So if I can do it very like without the intervention of human beings, to do like in when the rover was moving around the Mars lunar surface, so we were there in that. So where we were telling you go this way, go this way, you collect the data there. Okay, this has to be done on its own so that the number of missions can be more and number of people required will be less, so that it will be a cost effective. So you can see NASA is planning to send 3 rovers which do not need any human to control them. They will take the decision on their own. They will move left and right based on whether they can navigate that particular, say, crater or not. So this is similar to the Pragya rover which we sent. This everything is without human intervention. It is going around, collecting the information and sending back. Oh, I have found something very interesting here. Okay. Okay. So now what happens is like asteroid sample collection. So what kind of minerals are there? So there is like whenever humans are very creative in terms of finding something useful, not just for scientific purposes, for their own purposes. For example, people found gold and it's a very good conductor, but does anyone see like everyone using it for a conductor? Some people make a necklace or a bangle out of it, right? So similarly, the asteroid sample, now there is like rare earth materials for your EV batteries and all are becoming very scarce. So can I find it in asteroid? So which is very, very abundant. So I don't have to mine. For example, if I am lucky that I have found an asteroid of lithium, then what I can do is I can bring back a lot of material from there so that I don't have to dug our own earth. So this is a sample return mission. So what they did, this is a small probe. It touched here. When it touched, it is like a vacuum pump. So it pumps, then inside the material is sucked and that is brought back to earth. Okay. This touching, I'll show you how interesting it is. Okay. So this is the surface of an asteroid, OSIRIS-X, it is called the mission. You see, it just blew and the samples got stuck into that end effector. Okay. So as like if you have seen the theme of overall my discussion, right? I've been telling money, like it's very costly to do these experiments. So we are, or the space as a community is looking for some disruption. Maybe I invite some of you to do that disruption. So you can follow like the whole story was to give you a structure, right? So is there any structure for disruptive technology? Yes, there is. So Galileo, what he did, he understood that I have to observe the scientific like other planetary bodies. So what he did, he developed a like the telescope was already there, like where people with the mirrors, they were able to do. So what he did, he honed it so that he can look and get the like pictures. So, or he can see. So that's how like very latent in some other areas was applied, so that this problem solving can lead to a spiral of scientific and technical. So right now we have so many cameras, all because of Galileo's thinking at that point of time. So one of you might think of similar to Galileo, and so that you can leave both science and engineering enhanced. So I would call him a disruptive. So you are welcome for a disruption developer, a disruptive technology. With this, I will end my presentation. I hope it was not too boring, and I hope none of you were hoping that when will this end.
No way, sir. Madhuri?
Yes.
I'll stop sharing screen. Yeah.
Thank you so much, sir, for the highly informative and inspiring session on platforms for planetary missions. We hope everyone enjoyed the session and gained a better understanding of fascinating world of planetary exploration. And now it is the time for the moment we announced right at the beginning, the question and answer challenge. A question based on today's second talk will now be given. So participants, remember the rule. The participant who sends the correct answer first to the given number will win the exciting cash prize. Send send you send your answer to the number which is going to be displayed on the screen now. So get ready, think fast, answer correctly, and you could be our next winner. Let's begin the challenge. The question number 1 is like, next question, ma'am. Question, please.
Wait, Madhuri.
Okay, ma'am. So participants, be alert and get ready to send your answers to the questions displayed before on the screen. And the participants who participated in the space day activity, that competition, be ready. The winners list will be announced soon.
And
Here is the question.
Mm.
Here is the question about the second talk. The question is, ma'am, question.
display agilva.
No, ma'am. Still the phone number is there on the screen.
Okay, right. Now?
Yes, ma'am.
Hmm.
The 4 pillars of planetary exploration is based on which book? Here are the options. Option A, Horizon 2161, Horizon 2016, Horizon 2106, and Horizon 2061. Send the answers as fast as possible.
We can go for second question.
Yes, the second question is like,
Is it visible?
no, ma'am.
Now?
The second question is like, Chandrayaan-1 carried on object for impact. What's the object called? Here are the options. Option A, Lunar Impact Module. Option B, Moon Impact Probe. Option C, Chandrayaan Landing Module. Option D, Lunar Exploration Probe. Yes. The participants who answered correctly and fastly for these questions will be announced later. On behalf of all the participants, I thank our speaker, Dr. Sham Rao sir, for this amazing session. Thank you so much, sir, for this beautiful talk.
You're
Here
welcome.
is the yes, sir. Thank you so much.
Madhuri, wait. Sir, we are not able to take the questions because of the shortage of time. So if any queries, you can, participants, if you have any queries, you can text in our WhatsApp group. I have already posted in chat box. And also you can, who are in competition group, there also you can post. We can communicate to resource persons. Okay. Sir, Sham sir, thank you very much. It was very interesting talk, sir.
Okay, you're welcome, ma'am. Thank you for providing me the opportunity to
It's
speak.
our pleasure, sir. Okay. Madhuri, go ahead.
Here is the most exciting part for all the participants. As a part of our science day activity, we conducted a study using satellite images of a selected location. Participants compared images from an earlier period and with the recent images to understand how the places has changed over time. To announce the best presentation and winners of this competition, we have a special guest. A brief introduction about our guest Raghavendra sir. Raghavendra SP is a research scientist at ISRO's National Remote Sensing Center, specializing in Geo AI, remote sensing, and disaster risk monitoring, with an MTech in geoinformatics and a BE in civil engineering. He applies AI and Earth observation technologies to sustainable agriculture, water security, landslides warning systems, and the UN Sustainable Development Goals. He is also passionate about Kannada literature, poetry, creative writing, trekking, and strategizing. Now, our guest is ready to announce the winners. Hope all of you are excited for this moment. Now, over to Raghavendra sir.
Before that, I have a small announcement. We have providing e-certificate to the all the participants who are attended our National Space Day talk, Twin Talks. They can fill that Google form and they'll get the e-certificate through their mail. It's in chat box. Over to Raghavendra sir.
Yeah, thank you. Thank you, Madhuri. Thank you, Supriya ma'am. Hope this screen is visible. Namaskara, everyone.
Yes,
Hope
sir.
all are excited. Yeah, before I start, I will just take 2 minutes to say what happened. 3 years ago, while I was doing my MTech, there was this telemetry day organized at Karnataka Science and Technology Department. There, I won the quiz competition, and the award was given by our Srinath sir, senior scientist from ISTRAC, and Guru Prasad sir, who is the director of now Jawaharlal Nehru Planetarium. That encouragement brought me here. Now I'm working as a research scientist at National Remote Sensing Center, ISRO. So today it's a great opportunity to be a part of the orientation and judging committee of this event organized on National Space Day on Bhu Parivartane, the change detection through satellite imagery. First of all, it was like a full circle that was coming by. When I was a student, I participated in many things. Now, working in this committee as a judge was just a tough challenge. Last week, last week we had an opportunity for giving the orientation to the students, and more than 45 plus participants, students have been taken up this initiative and done exceptionally well. And it is very challenging and difficult to take the best out of the best, because most of them did the best already, and the judgment was little crucial. As Vyasa had challenges while writing Mahabharata, same here. Then Ganesha appeared here. Similarly, our Ganesh assisted me in compiling all those videos together and giving me support in choosing the best out of this. Many of the work included were the change detection in airport, from Mumbai airport to Kempegowda International Airport, and many more, to GLOF to Los Angeles urban sprawl. So it was very encouraging to see the young minds innovatively seeing the Earth from the space and doing the analysis over satellite imagery. What impressed me most was not just the topics, but the curiosity behind the young minds. The students have explored the platforms such as ISRO's Bhuvan portal, Google Earth Engine, Google Earth Pro, as well as NASA dataset. And I must admit that after seeing so many excellent projects and selecting the best was almost like asking a satellite to choose the best or the favorite cloud from the space. So the enthusiasm I saw today would really cultivate your topic now tomorrow into a problem statement where it can solve a real world problem or make a mission by itself. So finally, I would like to congratulate all the participants. Keep experimenting, keep trying, and keep innovating and building for the future, for the India, for the world. So I congratulate all the participants in all, and it was very difficult to take the best out of the best, but I've done a little justice in choosing what to say, the top people, not to say a top people, but the best out of the best was a difficult challenge, but the results are here. So there were two categories under the age group between 11 to 16 and 17 to 22. So first let us go to the age group 11 to 16. And the complimentary prize goes to Ritu Devraj from Sharda Shri Public School on the topic the change detection in Kempegowda Airport. Congratulations to Ritu Devraj. And the second complimentary prize goes to Ardhika Kotre from Purna Pragna Education Center, Indiranagar. She has done exceptionally good work on South Lonak Lake Dwarf outburst using NRAC's dataset. Congratulations. And the third prize goes to Malini Rao from Purna Pragna Education Center, and she has seen the RLC change detection using NASA image. Congratulations, Manali Rao. Now, coming to third prize goes to Sanjana GM from Vidyanidhi Public School, Gauri Bidnor, and the work was on Sandur mines, and the presentation was exceptionally well. Congratulations, Sanjana. The second prize goes to Govind E. Naveen from Trishur from Devamata CMI Public School. He did exceptionally well in taking the given data and seeing the urban sprawl, and the presentation was up to the mark. Although he was from a young category, his mind and the inspiration, the way he analyzed the data set was most encouraging. Congratulations, Govind E. Naveen. Finally, the first prize under the category of age group between 11 to 16 goes to Sumant SN from Purna Pragna Education Center. The topic was seeing the urban sprawl in Sule Ring Road, the urban change using Google Earth images. Congratulations, Sumant. Congratulations to all the participants under 11 to 17 age group. Now, let us go to the age group category between 17 to 22. The second prize goes to Lakshmi from Vidyavartaka College. She has done a work on Las Vegas urban sprawl using NASA WildView dataset. Congratulations, Lakshmi. And finally, the first prize goes to Vinodesh Shanbo from Nite Meenakshi Institute of Technology. He has done exceptionally good work of seeing the urban change detection of Mangalore region using NDVI analysis. Finally, I would like to congratulate each and everyone for showing your enthusiasm in participating in this event. Now, in the future, we will be organizing more such events where we can see how your young minds can turn problem into solutions. Thank you. Vande Mataram.
Thank you, Raghavendra sir, for announcing the participants' active work and appreciating them and judging them on their activity. And we have to thank Purna Pragna Education Center, Indiranagar, who the school students, more than 20 students have participated. And Delhi Public School also, more than 10 students have been participated. We are very thankful to those schools who circulated our activity poster among the groups, and other schools also, schools and colleges, but we had more number of participation from these schools. We are very thankful to both the schools. And here a small information who got the prizes announcement list names and all. We are equally distributing the cash money to all the participants. We are not differentiating 1, 2, 3 like that. Just we are selected best out of 45 videos we selected, which is very difficult. Raghavendra sir was the one person who struggled behind that. Really, 45 to 3 is very difficult for us. So that's why we categorize both different age groups, and also we took 4 extra members. So we are communicating after this session. We will communicate those who got selected, and we will distribute our cash money among them. And we thank to Srinath sir and Raghavendra sir for all the efforts. We are we are doing some activity, but backbone is Srinath sir and Raghavendra sir for this session, for this event. We are very thankful, and I want to thank all the participants, which are very unique activity it was, and you people made very interesting videos and all. Your efforts and your parents' efforts are very truly appreciable. And I want to appreciate or thank our team members, Pratiksha, Sai Madhuri, Uma Devi, and Ganesh, Akhil, Ranganath, and all the other parties, other creative members who are very supportive in successful in this event. We are very thankful to all the participant and jury members for this event. And I think if anybody wants to share your opinion, you can raise your hand. Who got the anything you want to express, you can raise the hand. We can unmute your. If anybody wants to talk, winner side or any other, you want to express your experience, there is a two. Yes. Okay, 1 minute. Yes, you can unmute and you can speak out. Duhitra. Yes.
I actually love all the knowledge you guys shared. I learned many things also.
Your audio is not clear, ma. Again, you can unmute and
Thank you for all the knowledge you guys shared. I actually appreciate it. I don't care about the prizes, but I learned a lot about space.
this what we used to bring among the participants. It's an opportunity to learn something. It's not about gaining some money or anything. You gain the knowledge. That is the ultimate thing. We are supposed to conduct this type of programs. We are very happy about that 40 videos. We are sharing that all the videos in on our Instagram page. So you can check it out after 1 or 2 days. Every video we are going to share on our social media, so that it should be preserved somewhere. Their efforts should be retained, so that we are planning that thing. So Govind, you can
Duhitra, just a minute. Duhitra, you have done an exceptional work. I have seen your work on Kalkare Lake. It is more than winning anything. You have won our hearts in doing those analysis. At this engaged, doing an analysis on lake is a very good thing, and your work was also very good. Congratulations and wish you all the best.
Thank you, sir.
Govind.
My name is Govind. This was a
very good experience for me. This was my first experience, and it was a very good. It was very good, and I got a lot of knowledge about space. I actually didn't expect any prize, but I suddenly just got the second prize in my age group.
It was not suddenly, Govind. You have done a very good work. Seeing the urban sprawl, that too, you have used our ISRO's Bhuvan data, and it was really loving and touching to see your work there. Congratulations.
Thank you, sir.
Vinod?
Hello, everyone. First of all, this event was really great. I had a lot of fun and also interest doing this. Sir, I wanted to specially ask you, like, I am very much interested in this field, especially the GIS remote science. And I have been preparing a research paper. I mean, it's not yet done, but I wanted to ask, sir, in future, can I, like, I am currently in my electronics and communication BTech at NITE University, but I wanted to ask, like, whether I can get any job or research kind of thing in organization like ISRO or DRDO.
Yes, we know your work on NDVI urban sprawl analysis was very good, and it was like a mini research paper itself. And doing that at the engineering level is exceptionally good. We people did all those analysis only when we came to MTech. We didn't know the NDVI term as well. But at your age, you have done a very good work. My number is on the group. You can ping me, or else I'll send my email. You can write to me. We will discuss. If anything is there, I will surely guide you.
Yes, sir.
There is
Sure,
a
sir.
lot of
Thank you.
opportunity for electrical electronics people as well, because the sensor, most of the things are designed, and even in the field of remote sensing and GIS, there is a very good opportunity in the upcoming days. You can write to me. My number is on WhatsApp. You can ping me, or else I'll send my email to you now.
Yes, sir.
Okay.
Sure, sir. Thank you.
Congratulations. Yeah.
Naveen?
Yes. Good evening. Good evening, madam. My name is Sumant. Thank you for this opportunity. I learned how to use this historical imagery and learned many things, how to use satellite images. Thank you.
Very good work, Sumant. Congratulations. Your work on this urban Kempegoda layout was an eye opener to all the urban development ministers.
Thank you, sir.
Thank you for Suman mother. Behind Suman mother, behind Suman mother is backbone. I hope.
Yes, ma'am. True. Actually, even for me, it was a first experience. We could learn many things out of this.
Yes, ma'am. Thank you.
Thank you so
Thank you
much.
for the support. Okay, I think we can stop taking the opinions. And now, 4 questions and answer who got the prize money. That will we are going to announce now. Over to Sai Madhuri.
Okay, ma'am. As we informed question and answer challenge during the 2 talks, here we have the winners. The talk winner for the first talk, Takshashil Kamle, the first winner. Congratulations, Takshashil. And the second winner for the first talk is Dhanya. Congratulations, Dhanya. So the winners for the second talk are Viresh Mandi, the first winner. Congratulations, Viresh. And the second winner is congratulations, Vismaya. You are the second winner for the second talk. Congratulations for all the winners. And before we conclude, we have one more request for all our participants. Today's program may be coming to an end, but your journey with Creactive doesn't have to. Creactive continues to bring you interesting science talks, competitions, educational activities, and opportunities to learn and explore. So stay connected with us on social media. Follow our Creactive Gauri Vidnur at Creactive GBD and stay updated. about our upcoming programs and activities. You can also visit our website www.creactive.organization.in. So don't forget to follow, like, share, and stay connected with our Creactive. As we come to the end of this wonderful
Madhuri,
National Science Day celebration,
one more announcement. We will share e-certificate link for the participants competition who are participated in that group, WhatsApp group. So here we
Yes, ma'am.
shared e-certificate for the talk. National Space Day Special Twin Talk e-certificate link has been shared in the chat box. Okay, if you want to join Creactive WhatsApp group, that link also shared in the chat box.
Yes.
Okay.
So as we come to the end of this wonderful National Space Day celebration, we express our heartfelt gratitude to our esteemed resource persons, Shri Amitabh and Dr. Shamrao, for sharing their valuable knowledge and inspiring us. And a special thanks to our Creactive volunteers for your support. And a special thanks to Raghavendra sir and Srinath sir and Supriya ma'am. And a big thank to every participant who joined us and made this celebration more meaningful and exciting. Today we celebrated not just space but also curiosity, science, technology, and the spirit of exploration. Let us continue to ask questions, seek answers, and explore the unknown. Keep exploring, keep learning, keep dreaming behind the stars. Thank you. Thank you all for being a part of Creactive Weekend Talk. National Space Day 2026.
And at last we can take one photo. Who are interested, they can switch on the video so that we can take one screenshot. Make it fast. We are taking photo screenshot. Okay. Make it hurry. Hurry up, hurry up. Okay, I think Pratiksha. Uma Devi. Okay. We'll share in the group. Okay. Thank you all. Yes. Okay. Madhuri.
Yes, ma'am.
Conclude.
Thank you all for joining us and for your valuable